This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 138, a look at digital twins with Ansys tools, along with news and events from the world of Ansys. Greetings, long time no see, or here, I guess. My name's Eric Miller, and I'm one of PADT's 3 owners and your host for these podcasts. We did our last episode back in July when we talked about the Ansys Synopsys merger. Then our tech support team got very busy with some engagements with helping large customers with new products and features. And the Ansys team, who often comes on the team, got very busy with post-merger things. So everything we had scheduled didn't happen. Then I got really busy with all sorts of stuff that I've got my fingers in. And well, here we are a couple months later without an episode. So I apologize for that. I guess next month finally got here. So big thanks to you and those who subscribe for sticking with us through our little gaps that we have occasionally. We're not gone. We just took an end-planned break. We're not changing the name. We're not really adjusting much of anything, except we'll talk about it a little bit later. We're not going to look at the stock price so much. So what's been going on that kept us so busy since the end of July? And we had August, September, and almost all of November. Recording this on the 26th, so most of November's come and gone. Like I said, we've been really, really busy, basically helping customers do more with Ansys tools. It's been really good to see new teams, new users, or new products to older users really taking off and spending time helping them be more effective with that. And it's not just mechanical fluent and HFSS that we're spending a lot of time with. It's great to see that it's other tools. We've seen really cool projects that I wish we could share with you. And we keep asking our customers if they'll come on and talk about it. But, it's always, there's legal issues. If you're a listener and you want to talk about how you use Ansys, please do reach out to podcast@padtinc.com. We'd love to talk to you. And we hope to get more customers and Ansys folks on soon to talk about real world applications. So, one of the things you may be wondering about is how did the acquisition of Ansys by Synopsys impact things? From our perspective as a channel partner and as users, the paperwork's changed, where we process things, how we do things, some of the rules, things like that have changed, but nothing significant. The biggest task we've had since the acquisition is finding all the places we had an Ansys logo and changing it to the Ansys logo with, I think it's a Synopsys part of, or Ansys part of Synopsys now. So that's been our biggest task so far. It's been good. And, the sales team as well as the support team has really enjoyed what little they've had to deal with on the transition side. It's all been very positive. Another reason why we were busy was because here at PADT, we held our annual open house, and it's called Nerdtoberfest. We don't keep an official count of how many people come, but the guy that we hired to do the barbecue for the event said he served 840 different meals. So I'm guessing some had multiple servings and others didn't have any. So, we think around 750 to 800 people showed up, which is great. This year, we really focused on Ansys and simulation, and the crowd really responded positively. We're kind of on a mission to explain what simulation is to folks who don't do it every day and to non-engineers. So it was a big part of that event. So you can read all about Nerdtoberfest as well as other things on our blog, which is at our website, padtinc.com/blog. So do check it out. There's some cool pictures in there. There's a slideshow that kind of shows what went on. So if you weren't here, or if you were, you can see what happened. And it was a lot of fun. It was a busy evening. I saw a lot of people, and we hope to be bigger and better next year. You may have also seen in our newsletter, if you get our newsletter, or if you follow us on LinkedIn or follow me on LinkedIn, as well as the multiple news stories out there in the media, that PADT is now the North American distributor of the robotic large format additive manufacturing system from Rapid Fusion. So this is basically a very large 3D printing device that uses a kind of a traditional large robot arm to hold the printing mechanisms. It's a pretty cool thing. Where does that fit into the simulation world? Well, one of the things we're really excited about, and one of the reasons why we became a distributor is it makes really big parts, and those big parts need structural simulation, right? And so we're really excited about doing that more. Working, it does some really cool materials with, chopped fiber and things like that, and engineered plastics. It's pretty much anything you can get a pellet of, you can extrude. So if you're into large format 3D printing, do check that out. Again, it's the Rapid Fusion machine, and we hope to be sharing some simulations we do for customers on that at some point. So anyhow, all that being said, and apologies given, it's good to be back and talking about Ansys on the podcast. So let's get into our discussion for this episode. If you've been paying attention, you will see that Ansys, from a marketing standpoint, is really talking a lot about digital twins. A lot of people are talking about digital twins. I've gone to a couple conferences where there were tracks on their version of what a digital twin is. And so sometimes I get a little confused about it. So I asked Josh and Noah from our support team to come on over and educate me on the subject. And hopefully you'll benefit from our discussion as well. So here it is.
It's been a while since we've had one of these conversations. We're here today to talk about a topic that a lot of people are talking about, digital twins. And we're going to be speaking with two of the engineers here on PADT's technical support team, Noah Asherbranner, I can't remember now.
Asherbranner.
Branner, thank you. And Josh Stout, to kind of educate me, really, and you, our listeners, on where things are with digital twins in the Ansys world now. So if you get any kind of marketing information from Ansys, you'll see them mentioning it quite a bit. It's an area of interest of customers and in the industry. So we want to learn a little bit more about it and really also focus on those of you who are listeners that might be feeding digital twins and what does that look like. So we'll go ahead and get started with introductions. Josh, why don't you go ahead and introduce yourself, what you do here at PADT, what your background is, all that kind of thing.
Yeah, thanks, Eric. So my name is Josh Stout. I'm one of the application engineers here at PADT, and tomorrow is my 6-year anniversary. I just had to check that. Yeah, so it's been a fun 6 years here. I'm mechanical engineering by education. I fill a systems engineer role at PADT, so I do a little bit of everything. That's kind of what it comes down to. Digital twin stuff we're talking about today, workflow automation, scripting, electronics reliability. So I get to play with everything.
Excellent. Very good. And Noah?
Thanks, Eric. I'm Noah Asherbranner, another application engineer here based out of Tempe, Arizona. So, at our headquarters, my background is in robotics and autonomous systems, and now I'm also taking on a systems engineering role here at PADT, primarily around, digital twins and requirements verification.
Very cool.
And I've been with PADT a couple of years now, I think coming up on 3, which is really exciting to say out loud.
Yeah. It's been a great ride with both of you guys, and what's been great with both of you is that, we started my career when we started PADT, it was all component level stuff, right? And over time, system level simulation has really grown in the Ansys world, and you guys have been a key part of making that happen. So we really appreciate helping us move into this world as a bigger system level. So, there's a lot of definitions out there for digital twin. If you look it up on the internet, it's whatever a given company is selling that they call digital twin. But I'll ask you guys, how do you define digital twin?
So I guess from my side, I tend to take the sort of Ansys definition to it. The key piece really there is the word twin. So when they say twin, they're talking about a digital representation of something that is then tied to the real world asset. So basically when one of those changes, the other one also changes. Typically that goes in the direction of you have a real world asset that is operating under some condition, you're measuring stuff about it, those measurements get passed over to the digital side, which then update kind of the rest of it. So I think that's kind of the official answer. I think the more practical answer is basically what you had mentioned. It's whatever the customer says it is. So that's always the first part of the conversation, is trying to understand what do they actually want, what are they talking about in any given discussion.
Noah, anything to add to that?
Yeah, I think, connecting to that real life asset is a huge piece of it, and understanding how that asset is going to perform in the field, throughout its operation from, when it first gets deployed into the field all the way through, maintenance cycles and eventually it's, kind of end of life. So, having that full kind of thread is really important to today's engineering challenges.
Yeah, I think I've also heard the term digital thread used, which is kind of that whole life cycle thing, which is really important, right? So it's not just that initial driving your design with simulation, which of course we do all the time, but when we get into this digital twin world, we're really dealing with the life cycle of a product or a system. So it's a good way to think about it. Love it. So what's the, and there's been some name changes, but what's the primary tool that an engineer would look at, an Ansys user would look at if their boss came in and said, we need a digital twin of the X37-5? What tool would they use to create that?
Yeah, so I think really your digital twin, it comes from a number of different simulation tools. Right, you're analyzing that system performance kind of at a high level, right? And so you're going to be feeding in from some of your more traditional tools that you're used to. But once you get into the actual building of the twin, you're going to use a tool called, Ansys Twin AI. And so that's bringing in that data from a lot of different simulations. Sometimes it's scripts and, logic. And what that really allows you to do is understand that full system performance and how each of those different simulations you're building kind of link together for the big picture.
Gotcha. So one of the things that I think is very important to these is that we're not like doing a full Fluent solve as part of a digital twin or a full Ansys mechanical or HFSS solve, right? This kind of gets into that whole world of reduced order models. Either you guys want to kind of explain what a reduced order model is and where they fit into the digital twin world?
Yeah, that's something that I certainly deal with routinely. So there are lots of different flavors of reduced order models. And basically what it comes down to is, rather than having the entire finite element representation of some geometry, you're boiling it down to a simpler representation. So while we could, a really simple example, we could model maybe a structural bracket, for instance. If you do the full FEA model, you have a mesh behind that, you have some boundary conditions. If you're applying a load in a particular direction, then you have a fixed support, like a simple cantilever. So there are so many degrees of freedom that can go into that when you fully model the whole thing. That's what makes it expensive. If you can instead boil that down to, here's my force value that's being applied, here's my total deflection as a result, that representation becomes a reduced order model.
Gotcha.
So, of course, that works fantastically in simple systems. If it's linear, it'll be perfectly accurate. Even if it's nonlinear, if we understand what that nonlinearity, looks like, then we can still model it perfectly. But it's basically boiling it down with some assumptions. So, high level, that's what a reduced order model is. Lots of ways to tackle it. Could do scalars, like in that example. There are even ways to do entire sets of field data. So like if you take a picture of that bracket, for instance, and you have a color bar associated with it, like you could use tools to turn that into a reduced order model potentially. So it can go in a lot of different directions.
Cool. And how does one create a reduced order model? Is it something that you kind of do external? Do we have tools in the Ansys suite, or is it both?
Yeah, so one of the probably best sort of tools to do it would be just built directly into Twin AI. Formerly, it was known as Twin Builder, and so that process would be actually bringing in simulation data and generating the reduced order model, just directly from the simulations that you're performing. And so you can kind of do that through the sort of interface built into Twin AI, and there's a kind of step-by-step process. There's a lot of training material on that as well. But, if you're able to get that simulation data, maybe you've built it yourself, you should be able to, generate that reduced order model without much difficulty.
Okay. And then you take all those and you put them together in Ansys Twin AI, is that correct?
Yeah, for the most part. So when you're building up these sorts of simulations, sometimes they might be static, other times they might be transient, and so if you're getting into, something transient, you might need to worry about your different time steps. With the Twin AI tool, you can do things in really short time scales or really long, and taking advantage of those reduced order models allow you to simulate, very long periods of time very quickly.
I love that. So, what is the thing that you should really think about? So let's say you got assigned to do one of these, but you're going to build a digital twin of that made-up product that I said. You're going to use Twin Builder and some core Ansys tools. What else do you need to know, or should you worry about or plan out before you get started?
So I can say from my end, one of the things that I am highly involved in is just general workflow automation.
Yeah.
So being able to effectively generate that data in the first place is obviously is really important. So being able to automatically do that is even better. As part of that, we kind of need to understand going into a project, like what is the operating envelope? Because if you have data that represents the real thing, like that's great. But it needs to actually cover the range of data that we're interested in at the end. So if we end up doing like accidental extrapolation outside of it, then our accuracy can just tremendously drop, and there's not really anything we can do about it. You can always go back and add more data afterwards, but the more of it that you can kind of get defined ahead of time, I think the more efficient, the more effective the process is going to be.
I think one other thing that you kind of want to consider when you're building a digital twin is understanding what you'd like out of your digital twin as well, right? You can characterize your system a number of ways, but when you're trying to understand what you're trying to get out of the, that kind of co-simulation of sorts, that's really important. Bringing in the appropriate simulations and data for your purpose is just as important as having the accurate simulations themselves.
Yeah,
that's a good point. Go ahead.
Kind of piggybacking on that, I was just reminded, one of the things I think is really special about digital twins is the concept of virtual sensors. So like if you set up your digital twins so that all the information you're getting back is something that you could just measure, like the value of that is relatively limited. So as Noah pointed out, you really want to think about what would actually be beneficial for your system. Like we want to get something that's actually like different than we would be able to get from the real world asset.
That's a good point. And it seems like you also could do what ifs, right? So instead of going out to your gizmo and turning the dials on it and seeing what happens, you can do that virtually. Is that what a lot of people want to do with it?
Yeah, that's exactly what we're seeing with some of our customers is that what if, you've got an existing platform where you might want to change out a specific component or subsystem within that platform, and understanding that big picture of how's this new platform, with these updated components, how's this going to perform in the field? That's the important, the $1 million question. And so being able to switch out the components within your digital twin, understand that behavior without actually going out and building it, can be really powerful.
Cool. What about predictive analytics? It just kind of popped in my head that you could do that as well, like figure out that, or predictive maintenance, I guess is the right term, that my digital twin is telling me that this is going to be a problem in the future. Is that something as well?
Yeah, I would say so. For many, many years, I think one of the flagship kind of examples of something like this is a digital twin of maybe a jet turbine.
Yeah.
So when you're initially designing one of those things, maybe it has a certain number of cycles that you assume is safe between maintenance periods. But inevitably, every turbine is going to be run a little bit differently. Maybe you have to climb a little bit fast to get out of the storm. maybe something else that you weren't expecting happens. Like those things can add, a little accelerated wear on the system, and you'd like to be able to track that. So if you had something like a digital twin that was continuously running alongside the real thing, and then it was fed some input that indicated that it was, wearing at an accelerated pace, like that's the kind of thing that we could absolutely track in an application like that. I mean, you still need some way to process the data and understand what that looks like, but absolutely.
I love that. That's a good point. That's where I first encountered it. I don't even think we called it digital twin, but I think a digital mock-up is what we called it back then. But the hooking the control system up to system level reduced order model of a jet engine and being able to exercise it and take that sensor data and see what it means. That was kind of the first time I ran into it. So what other industries do you see it in? Jet engines are one. I always think of industrial applications. How broad is the application that this could help?
Yeah, one area where I definitely see this, really building up in interest and where it's kind of going is that space tech sort of realm. Getting into orbit, some of the new satellites going on. I have heard of all sorts of ways where this could be beneficial, whether it's delivering different payloads in space to, doing maintenance on satellites that are already in orbit, things like that, where you might want to understand how these two systems are going to behave once they become one, even if it's temporary. I think there's a lot of potential there, and something that we're definitely seeing a lot more interest from industry.
I love that. Josh, you got another industry like semiconductor? Is it starting to show up there? Is that something?
Yeah, I mean, I could definitely imagine semiconductor. That we tend to have fewer customers at PADT in that space. The one that I have seen some interest in that hasn't quite taken off yet is in automotive and ADAS especially. So, I think anything, it's similar to space in some ways. Like anything that is vaguely autonomous, it's good to be able to remotely track and kind of consider these things. But obviously the satellite is the extreme version of that. Like we can't go up there and test it. But, to a limited extent, without implying that we actually work with them. For instance, Waymo in Tempe, right there. Autonomous vehicles that drive around. There are all kinds of remote metrics that are involved with that. Like that could be considered a digital twin and certainly a good application.
Well, I know that some of the training that went on for autonomous vehicles uses digital twins too, so they can run it through a virtual city rather than a real city to train it. So, which gets into my next question, which is the name change from Ansys Twin Builder to Ansys Twin AI. What's the AI part of that? Is it using it to do AI simulation on the results? Is that what's going on there?
Yeah, so kind of what's going on with the Twin AI name and the implementation is about the hybrid analytics. So bringing in both your simulation data and coupling that with your real world, sensors and that sort of real life data now being coupled into one. So what that kind of allows, right, is improved accuracy of your digital twin, in that you're bringing in this both the best of both worlds. So you're getting improved accuracy and faster sort of generation of that data. And so there's a number of different algorithms that can be kind of applied to get closer to that like perfect match. So that's the big focus towards the hybrid analytics.
Gotcha. Cool. Yeah, it's all a brave new world. So what's what's an Ansys mechanical or fluent user to do in this space? How do they fit into this? They feed information to people building the digital twin. Is that kind of what you're seeing out there? Are they building the digital twin or both?
Yeah, what we're typically seeing, at least what I'm seeing in the customers I'm helping, is you'll have systems engineers that are kind of building the architecture for the digital twin. And they'll work closely with the mechanical engineers, the fluids engineers, that are kind of experts in their respective disciplines. And it'll be kind of a collaborative process to bring the appropriate simulation for this system level sort of application. And so it's a coupled process where you kind of put your heads together and build something up.
Yeah. Cool. Very good. What did I forget? Is there anything about digital twins you want to share with our listeners that we didn't talk about?
Go ahead, John.
Yeah, go ahead, John.
Yeah, maybe just honorable mention from my side. So, I mean, we've mostly been talking about twin AI and the stuff that's actually called twins. We talked a little bit about potential applications for those things, especially when it comes to reduced order models. Those can be described as reduced order models or digital twins or sometimes surrogate models. We can actually also make use of those for optimization problems. So there's another entire application area where we build these not for twinning purposes, but for like more of those design what-if type scenarios. So it's certainly a very wide area. Depending on what you're trying to get out of it, we might tackle it in a slightly different way. So keep an open mind. Anytime you hear digital twin, it could mean a lot of different things. It could be used in a lot of different ways.
Noah?
Yeah, I think this is, more focused towards just the Twin AI tool itself. I'm a big believer in SysML v2. And with, this year's sort of updates to the Twin AI tool, there's now the ability to export SysML to snippets based on, the ROMs and the simulations you're actually feeding in. And so if you're building kind of like that systems architecture, systems modeling language models, right, it's really a convenient way to get started and just bringing in your own simulation data and being able to pull SysML out. So
I love it. I love it.
Something I really enjoy.
Really get into that. The new slogan. I don't know how official it is, or if they kept it with the Synopsys acquisition. Is from silicon to systems, right? And we're definitely on the system side of this, and it's really exciting. All the different things we can do and how we can really tie everything together from a multi-physics standpoint and a multidiscipline standpoint and a multi-application standpoint, and really get useful information not just to the engineer doing design, but to the organization itself, right? I think digital twins kind of move simulation out into the enterprise a little bit more, which is kind of cool. We're not just in a basement, literally. Cool. All right. Well, that is it for today. I really want to thank you guys for giving me this information. I feel a little bit better educated on it, and hopefully our listeners are as well. And keep your eyes and ears peeled. I think we're going to see a lot of advances in this area, and it's going to improve with time. So thanks a lot, guys.
Yeah, it was a pleasure. Thanks so much for having us.
Thanks, Eric.
Thank you.
That was really great. I think I've got my head around the nuances of what makes a digital twin digital twin. And it's a real thing. It's not just a buzzword. There's a lot of uses to it, and we're seeing more and more people going down that road. So it's great to see. So if you're thinking about using digital twins or need some expert advice on how to create the ROMs, maybe build the system models, integrate sensor data, or deploy it, reach out to us. Let's see how we can help you. We've got some experience with this. You heard it from the guys, and there's people that weren't on the podcast today that also work in this area. So we're really eager to help you implement this folks. We love this stuff. And like I said, it's not just the two of them. There's others that can help. So just shoot us an email at info@padtinc.com or give us a call at 480-813-4884. We're here to help you go beyond the buzzwords. This one of the reasons why I wanted to cover this topic is because it's not a buzzword. It's a real thing, and help you build solutions that add real value. And, that kind of sounds like a commercial, and it's time for our commercial. And the reason why it sounded like a commercial, because it kind of is. Kind of got into it because no matter what you're doing in the world of simulation, PADT's tech support and consulting team are really here to help you. The other day, we were talking to a group within a long-term customer who want to drive their whole design process for the area that they're focused on, which we can't talk about, for more of a system level multi-physics. They're doing component simulation, but they want to do multi-physics system level simulation of their product lines that they're developing. And at first, this sounded like they wanted a vertical application. I love vertical applications, so everything looks like a vertical application to me. But after a few discussions, it sounded like they wanted something a little bit different, and we opted to propose a program where we will do some of the simulation here at PADT, our consulting team will. Then we'll come in and train their team to do it themselves, so the people that are doing component level to do the system level stuff, and then keep supporting that transition through mentoring that might lead into some automation. Maybe some of the steps will be turned into vertical apps. We'll see, but that's down the road. We're doing this more and more often as new engineers or engineers who are new to simulation join in at the companies that we serve, and they're doing some really spectacular engineering that benefits from all types of simulation. And we're seeing optics, photonics, high-frequency electromagnetics, fluids, system simulation. There's so much more that people are getting into, and we're finding that we can be really helpful in doing that as a service initially, and then coming in and teaching you how to do it, and then bringing in the mentoring team from the tech support folks to support you through that growth and make it even more effective. So again, if you want to contact us, let us know. You can reach out to us at info@padtinc.com and give us a call at 480-813-4884. So that's it for kind of 2-for-1 on commercials today. So we'll move on to talk a little bit about stock. So, in my notes, I've got talk about Ansys stock. Well, it's not Ansys stock anymore. It's Synopsys stock. And the truth of the matter is that we're not going to spend as much time talking about it because Synopsys is a big company. And although Ansys is doing really well from a sales standpoint and helping their numbers, it's relatively small compared to some of the very large enterprise deals they'll do with large foundries or large corporations. So it's not as important to those of you who are users as the Ansys stock itself was. I mean, we'll still talk about it because, if the stock's doing well, they'll spend more money on R&D. They might acquire new companies to join the Ansys family of products. Who knows? But we're not going to dig into it as deeply. Anyway, so let's dig into it not so deeply right now. So in July, after the acquisition officially closed, it really helped the stock price. SNPS, which is Synopsys stock, peaked around $650 per share. Then at the start of September, they released some not so great numbers on their quarterly performance, and they lost a ton of value, dropping around 40% to $387. So they went from $650 to $387 a share. They're back up to $400. I suspect they'll recover. But again, they're driven by some very large enterprise deals. So on the chip simulation and design side of things. So we'll see how it goes over time. So year to date, since January 1, the price of Synopsys is down 16.8%. And in contrast, S&P 500 is up 15%. So we'll look for that to recover, and we'll keep an eye on it and just kind of report the price and basic news about it, but won't dig as deeply. So let's look at Ansys-related Synopsys news. So if you go to the Synopsys news page, you will see lots of Ansys stories, which is really cool to see that already they've integrated those two things, and they feel, at least from a public marketing standpoint, that Ansys is an important product line. Most of the stories talk about the ongoing growth of the relationship between NVIDIA and the Ansys team at Synopsys. And I suspect also the rest of the Synopsys team. Look to see more of that partnership. The NVIDIA uses Ansys simulation tools as well as the whole Synopsys suite, I believe. And so that relationship is a two-way street. what I like about it is this is kind of what happened. Video games really paid for GPUs, and then Bitcoin mining was a big thing for GPUs, and that really helped make them better. And now it's AI. Everybody loves GPUs for AI. It's what NVIDIA makes. And we love it on the simulation side because we benefit from those really cool GPUs, and the cheaper they are and the faster they are and the bigger they are, the more we can benefit from that money. So we love it. Also, something in the news that does impact Ansys users is, if you remember, one of the things that held up the acquisition was that there was some overlap in the product line, not much. There's a Ansys product called Power Artist that Synopsys had a slightly better tool for, so they sold Power Artist. And then on the optics side, the other big optics tool that competed with now I'm forgetting the name of it, but that competed with the Ansys optics suite basically had to be sold as well. They sold both of those to Keysight Technologies. And so that was kind of the last official hurdle they needed to do post-acquisition. So that's done. The other thing that happened during the stock drop is that Synopsys swapped out their head of sales. They call them that person their chief revenue officer. It was Rick Mahoney, who those of you that have been Ansys users for a while may remember. He was the head of sales at Ansys for a while and left Ansys in 2022 to go join Synopsys. And it was good to see him for a little bit when we came back into the Synopsys fold. But the new person, Mike Elo, comes from Cadence and then Siemens, also a electrical type software, electrical chip design type software person, like Rick was, and we hope that he will do a great job. And so far, so good. So that's a little bit of a change that impacts those of us that resell Ansys, and probably, hopefully, just users will have a better experience on their end. So I kind of covered PADT news. We had an Oktoberfest. We did the Rapid Fusion, selling the Rapid Fusion for North America. That's pretty much it from a news here at PADT standpoint. Everything else is great. And then, next on the list is really my favorite 3 articles from the Ansys blog. So I had a lot to pick from since it's been 3 months pretty much since we last talked. I think that my favorite was an article called Views on the Future of Digital Engineering in the Age of AI. And we included a link to that in our newsletter as well. So this was at Simulation World, the conference that Ansys does for users and decision makers that are involved in, picking simulation tools. And they had a really good roundtable discussion. AI is here; it's everywhere. It's going to impact everything we do, and it was a really good talk about how what they call digital engineering, which is virtual representation using numerical simulation, is impacted by AI, and how people are doing things to take advantage of that, and what they're watching trend-wise to get there. So I really recommend you take a read on that. My second favorite one was called PyAnsys Heart. It's called PyAnsys Heart, Advancing Heart Modeling Through AI and Simulation. And as I mentioned earlier, I love vertical apps. That's what I used to do when I did real work. And I love anything heart simulation related because we've worked with a couple companies in that space over the years. And I don't know, it's just kind of cool. The heart is an amazing pump from a mechanical standpoint. So when I saw an article about a tool that combines scripting and heart simulation, that's a winner for me. And it's a really great example of creating a vertical app for a specific application that runs Ansys using PyAnsys. And it really took something that was a very complicated process into a kind of a game changer, a really powerful tool. So check that out, PyAnsys Heart, Advancing Heart Modeling Through AI and Simulation. And then my last pick of the 3 really gets into the whole GPU and AI thing, right? These are 2 mega trends in our industry, and it's called Accelerating Aerospace CFD Workflows with High Fidelity GPU and AI-Driven Simulation. And you should check this article out just because of the cool turbulence animations that are on there. And you may have seen them on social media because they've been sharing them because they're so cool. very powerful. It's not just good looking, but it actually tells you quite a bit, the simulation. It covers some advanced meshing enhancements on the CFD side of things, changes in turbulence, improvements in turbulence modeling, and then what they call using AI augmented workflows, which I think is an important topic that we need to look at. So it's really topical on two mega trends in our industry, AI and GPU. So do check it out. And that's my 3 picks for the blog. On our side of things, on our blog, if I look really closely from an Ansys standpoint, well, actually, there's a couple non-Ansys articles I want to point out. One is one that I just published the other day that's applicable to any engineer. It's called 10 Suggestions for Improved Project Management Communication. One of the things we found here in our consulting team is how important communication is. We know that. Of course it is, but it really makes a huge difference. And I gave 10 suggestions from our team on how to do better at project communication. So that's applicable for you, whether you're a project engineer or someone who works with project engineers. Also, for those doing thermal fluid simulation, Flownex, which is another product that we resell here for North America, thermal fluid 1D solver, we've got a comprehensive look at what's new in Flownex SE. That's not Solid Edge, but Flownex SE Release 3. SE stands for Simulation Environment. So Release 3 came out in the fall, and we kind of dig into what's cool there. If you're not familiar with the Flownex tool, it's a good article to kind of get a look at it. And that's pretty much it. We really didn't publish anything from an Ansys standpoint since we last talked, I think. Oh, I take that back. Cynthia did continue her look at some successful user group meetings that we've had recently. One was down at University of Arizona. So you can kind of talk about what we talked about or read about what we talked about down there. And then in August, Doug Otis published an article called Creating a User-Defined Result Showing Tabular Loads with Multiple Variables in Ansys Mechanical. And Cynthia again came back and wrote a really useful article that's doing very well from a click standpoint on exploring the new Ansys Optics site. So Ansys redid their Optics site, kind of combining all the products in one place. And it's a really cool site, very useful. And she's been pointing users that way. So she decided she'd take a guided tour of it. So check that one out. Explore the new Ansys Optics sites with me is what it's called. And that is it since the last podcast that's worth sharing with you on the PADT blog. Event-wise, if you're here in Phoenix, do come out. The only event we've got before the end of the year is on the same day, the YesPHX Winter Social and the AZ Tech Council Tech the Halls holiday party on the same day. So do come out and visit us at that. We'll be at both those events. And then in January, we're going to kick off 2026 the right way with a big bang at CES. I just saw the official announcement that we will be in the Ansys booth for that. So if you've never been to CES, if you think it's, just consumer electronics, it's not anymore. It's everything tech. It's huge. It's massive. It's in Las Vegas. Ansys has a massive booth, and they talk about a lot of the cool things they do with a lot of different customers. So again, that's CES at the beginning of January. Also in January, we'll be down in Tucson again to talk about optics. We'll be at Arizona Photonics Days for the 2 or 3 days that takes place before Optics West. And then we'll be in Anaheim, California for MD&M West again in February with a booth. So that's it so far for events. We'll be adding more to our calendar, so check those out. I did also want to mention that we've got a couple of job postings. We're really looking for great people like the 2 that were in our interview today. What we're hiring for is an application and support engineer for antennas. That's HFSS antenna stuff. We need more CFD people because more and more people are doing CFD. So we're looking for a CFD person as well to join the support team. On the sale, that's pretty much it from one more application engineer role, Ellis Dyna. That's another product that is growing in usage with our customer base. So we're looking for an application and support engineer. All three of those support engineer positions are here in Arizona. And then we have one open sales position right now. We're looking for an additional FlowNext account manager to help sell that tool across North America. So, and that's a remote position. Or you can be here in Phoenix. So yeah, we've got 5 openings. We're looking for the right people. We're really picky. So if you're interested or know someone that is, please send them to our website. You can go to About and then Careers, and you can see that. And we've got a couple more sales positions opening up, I think, before the end of the year. So check that out as well. So a lot to cover because we haven't talked in a while, but that's it. Thank you so much for listening. Thank you for subscribing. If you found this podcast and you're not subscribed, please do subscribe to it. Please like and share it. All those things that trendy podcasters say. I think it's like and share. But please do. We'd like to get more listeners and share our knowledge with other people. So spread the word out there. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode number 138. As a reminder, this podcast is not affiliated in any way with Synopsys, and the opinions expressed are those of the people on the show only and none of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions with an email to podcast@padtinc.com. See you next time.